Welcome to Data Analysis with Python, a comprehensive course tailored for geoscientists and professionals in the energy industry. This course is designed to equip you with the foundational tools and techniques of data analysis using Python, with a focus on applications relevant to your field. You'll learn how to manipulate and prepare your data using Pandas.
Let's begin by setting up Anaconda, which includes Jupyter Notebook, a primary platform for coding throughout this course. To get started, launch your web browser and look for the Anaconda distribution to download. Navigate to the download page on anaconda.com and proceed without signing up for an account. Select the appropriate installer for your operating system. Accept the terms to continue with the installation by clicking the I agree button. Choose the Just Me installation option. Chapter 3, Overview, Data Cleaning and Preparation. Course 405, Data Analysis with Python. This chapter focuses on essential techniques in data cleaning and preparation, a critical foundation for effective data analysis. We discuss various strategies to manage missing data, refine and transform raw data, and manipulate string variables to extract valuable insight. In this part of our Data Analysis with Python course, we demonstrate the use of the map and apply functions to calculate derived parameters such as porosity from existing data columns. This process involves using lambda functions for quick calculations and defining explicit functions for more complex formulas. Using lambda functions with map. Lambda functions provide a concise way to perform simple calculations. Here we calculate porosity phi den based on density using a straightforward formula embedded directly within the map function. Python, calculate porosity using a lambda function and the map method data equals data, density grcc, map lambda x 2.71 is x, slide 2.71 data. Print data frame. After calculating porosity with lambda, rock density GPRCC, minerals phi den 0.
Course 405. Data Analysis with Python. Chapter 5. Multi-level indexing, merge, and reshape. Chapter 5 of Data Analysis course using Python focuses on advanced data manipulation techniques, specifically dealing with multi-level indexing, reordering, and sorting levels. If you want to swap the levels from inner to outer or vice versa, we can use swap level method. This swap level takes two level numbers or names and returns a new object with the levels interchanged, but the data is otherwise unaltered. The df.swapLevel method in Pandas is used to swap the levels of a multi-index for either the rows or columns of a data frame. When you specify the names of the levels you want to swap, in this case, properties and key, the method rearranges the levels of the multi-index according to the order you provide. However, since df.swapLevel is typically used with the indices, row labels, or column labels if specified, and because your data frame df has named indices as properties and key, you should not directly pass the level names to df.swapLevel without specifying whether you're referring to the index or the columns. You can perform a more complex join operation that matches on both keys. This is a common scenario when you want to merge data based on a combination of identifiers rather than a single key. To merge these data frames on both key 1 and key 2, you use the pd.merge function specifying both keys as in the code. This merge operation performs an inner join by default, meaning it will only include rows that have matching values for both key 1 and key 2 in both left and right data frames. Given the specific keys in your data frames, the result data frame would include rows where both key 1 and key 2 match across left and right. This result shows that rows from both data frames are included if and only if they have the same key 1 and key 2 values. Since key 1 equal K1 and key 2 equal K0 have two matching rows in the right data frame, the corresponding row from the left data frame is duplicated to match each instance. The final data frame combines the columns from both left and right, showing A and B from left and C and D from right next to the matching keys. The how argument to merge specifies how to determine which keys are to be included in the resulting table. If a key combination does not appear in either the left or right tables, the values in the joined table will be NA. Here is a summary of the how options and their SQL equivalent names. Left outer join. Combines rows from the left data frame with matching rows in the right data frame. By using df.pivot, index equal minerals, columns equal metrics, values equal values, you restructure df so that the minerals column becomes the data frame index. The unique values in the metrics column become the column headers. The values column populates the new data frame with corresponding data. In df_w, the index consists of the unique mineral names, calcite, quartz, talc. There are two columns corresponding to the two metrics, color and moss_hardness, each filled with the respective values for each mineral. Course 405, Data Analysis with Python. Chapter 7, Grouping and Aggregation. Let's dive into Chapter 7 of Coding the Data Analysis course. Let's do another example with this method. Step 1. Setting the index df.set_index. Discovery_wellbore, main_area. This function call sets the columns discovery_wellbore and main_area as the new index, multi-level index or hierarchical index of the data frame. It effectively restructures the data frame to use these two columns as its row labels. The result is assigned to a new data frame named df_group_by_index2. This data frame now has a hierarchical index based on discovery_wellbore and main_area, but the same data as df otherwise.